We'll now start looking at an introduction to probability. And in order to do that, first we need to start with some definitions. The first thing we want to consider is a probability experiment. A probability experiment is a process that's based on chance, which leads to well-defined results. So there has to be a chance in performing this experiment, and the well-defined results means that we know everything that could possibly happen. The next definition we want to look at is an outcome. An outcome is the result of a single probability experiment. So if I roll a dice, the outcome would be a 2 if I had rolled a 2. If I flip a coin and get a heads, then the outcome is heads. It's what actually happened as a result of that probability experiment. We then have this idea of sample space. The sample space is all of the possible outcomes of the probability experiment. It's everything that could happen. So let's do a couple of examples of this before we get into a little more probability. We want to know what's the sample space for flipping 2 coins. What are all of the possible things that could happen? Well, we could get 2 heads. We could also get 2 tails. I could flip the first coin and get a heads and the second one get a tails, or I could get a tails on the first coin and a heads on the second. So this would be my sample space, and you'll notice order is very important. HT and TH are 2 different possible outcomes in my sample space. Another example, what's the sample space for rolling a die? Well, for rolling a die, we could roll a 1, a 2, a 3, 4, 5, or 6. So this would be my entire sample space, since this is everything that could happen. Before we actually get into probability, we'll need one more definition. And that's the definition of an event. An event is a set of outcomes for a probability experiment. So an outcome is just one thing that happens whenever I actually perform the experiment, like rolling a 2 on a die. An event could be just rolling a 2, but it could also be multiple things, like rolling an even number on a die. So the event are kind of the things that we actually want to happen, and the outcomes are the actual results. So if we have an event that we call E, then we have this P of E. That's the probability of event E. It's the number of outcomes in E divided by the total number of outcomes. And these can be given in terms of fractions, decimals, or percents. That's really a personal preference. So let's look at a few examples. Let's suppose we're rolling a single die, and we want to know the chance that we roll a 2, so the probability that we roll a 2. Well, there's 1 2 on a dice and 6 sides. So the probability of rolling a 2 would be 1 out of 6, since there's one outcome that would result in a 2 and 6 possible outcomes. What about the probability of rolling an odd number? Well, there are 3 odd numbers on a die, 1, 3, and 5, and there are 6 sides. So the probability would be 3 out of 6, or 1/2. What's the probability of rolling less than a 7? Well, all of the numbers on a dice are less than 7, so it would be 6 out of 6. Or just 1. One last one, what's the chance of rolling a number that's greater than a 6? None of the numbers on a die are greater than 6. So there are 0 sides that are greater than 6 and 6 total sides. So this time my probability would just be 0. Let's look at some very basic probability rules. The first of these states that 0 is less than or equal to the probability of E less than or equal to 1. So this says that a probability is always going to be between 0 and 1, and it can be 0 or 1. So it needs to be somewhere between, including these 2 numbers. As we saw in our last example, if an event E is impossible, then the probability of that event is 0. And on the other side of that, if an event is absolutely certain to occur, then the probability is equal to 1. And we also know that the sum of the probabilities of all of the outcomes is 1. If we consider every possible thing that could happen and add up all of those probabilities, it's going to be 1. And this comes from the fact that something is certain to happen. Something has to happen. So if we look at all of the probabilities together, they need to be equal to 1.